Hello, hello, hello. Okay, okay. So let's begin our daily talk. Okay, okay. So in this, okay. So in this video, I'll try to focus on the concepts of English, which is very important for the interviews. So interviewer generally asks a question about cycle, how you can find a cycle in our linked list. So it is, and then cycle, which is also a very important question. And then after that, you can say the length of the cycle is also, these are all part of a single algorithm which we generally solve with slow fast. And after that we also another type of problem is merge case sorted list. This is also a very important problem. So let's discuss the first problem, like finding the cycle in our list. So how can you find the cycle in a list? So let's say you have a list. So this is the link list you have. In this you do not have any cycle. Let's begin the, let's say this is a link list. In this we clearly see this had a cycle. So in this we can easily find how we can start. So first of all, here two pointers, slow fast. One is red, the other one is also red. So start the pointers here, slow and fast, and then start the while loop and run this while loop until fast start next is not null. This should be not null, this should be not null. Then you can run. And then shift this fast pointer to, and this slow to slow dot next, and then write a condition if slow is equal to false fast, then return true. So this is our condition for a cycle. Let's try run this question. So this question is very easy. Like here, slow pointer is here, and the fast pointer is here. In the next iteration, our fast pointer goes here, our slow pointer goes here. Then in the next iteration, our fast pointer goes here, our slow pointer goes here. Then in the next iteration, our fast goes here, and then it goes here. And after that, in the fast is here, and then slow is here. Then fast is here, and slow is here, fast is here, and then here slow is here, and then fast is also here. So see, both the pointers meet at a point. So this means our linked list has a cycle. If this is not if our linked list doesn't have a cycle, then there is no possibility of meeting these two pointers first. But if they are meeting, this means our list has a cycle. Let's say if our linked list is and then it's fast, slow goes here and fast goes here, and in the next slow goes here and fast goes out of the fast goes to null. So see, there is no chance. So there is no chance of meeting if the linked list is here. So this is our second question. This is our first question, which we solve using slow pointer and the fast pointer. And what is the time complexity of this question? So the time complexity of this is O of n. And what is the space complexity of this question is O of n, because we are not using any exact space. Hello. Okay, so let's begin with the second question. The second question is, what was the second question? Okay, so the second question is finding the starting point. So how you can find the starting point? So let's say yes, 1, 2, 3, 4, 5, 6, 7. Like this is a cycle. We have hello. Okay. Yeah, so let's begin. In this, we want to find the starting point. So how we will find the starting point of this, like we want to find this node. So how we can find? The first method we can use is map. Like you have a map, then in the map set key as a node and value as a frequency. So let's say first of all put one node and frequency one, then two node frequency one, then three node frequency one, then goes for four frequency one, then five, then five frequency one, then six frequency one, then seven frequency one, and then after that you got three, and in here already we have frequency one, but here we need this again. So if the node is same and frequency is already one, then this means 3 is our starting point. So by this method we can easily find. And the second method we can use is slow and fast. So what is slow and fast method? So in slow method and in fast method, like this, like these are the 2 pointers. So okay, like in this example we will see like 1 2 3 4 5 and then 6 and then 7. In this method, let's say we started slow and fast pointer here, then in the next step slow goes here, and the fast goes here. So whenever they meet first time, after first time meeting, what we do is we reset our slow pointer again to head, and our fast pointer, and then update both slow and fast pointers by one step. Then where they meet next time, this is our starting point. Okay, and the third question is length of cycle. So how we find length of cycle of a linked list? So let's say slow and fast meet at a point for the first time. After that, what we do, we keep our fast pointer as it is and move slow pointer by one node, and with that attach a variable one with counter, create a new variable counter, and then count it plus one, and what the stopping criteria is while slow not equal to fast, then counter plus one, slow is equal to slow dot next. So this is our code. Yes. Okay, then the fourth question is merge sorted k. Merge sorted k list. So what we do, like here we have 1 2 3 null. This is one list. 2 5 6, then 4 6 7, then 5 8 9 null. So these are 4 sorted lists, and what we want is we want to merge into a single list. So how we can do this? So for this purpose we can use the more optimal solution is we use mini. Okay, so in mini, what we know is that top element is the minimum element. Okay, so first take all the heads 1 2 3 4 1 2 4 6 and place it inside our mini. 1 2 4 6 and here on the top we get 1, then make a dummy node with -1 and then here you get tip, then make 1. After that, if this one had an egg, then put this 2 inside our and remove this one and now put 2 inside and then check which is smallest, then pop it out and make a new list. And then after that, if 2 comes out, then and then push the next one inside the menu, and this is the process by which we can solve the problem. Yeah, that's it. Okay, now in conclusion, the important topics for the interview purpose is arrays. Arrays are the most important data structures you should learn definitely. Then after that, binary search. These are also very important if you want to get the interview, because interview will ask some questions from this topic definitely. And then after that, heaps are also very important part in this. We have mean heap, we have max heap. There are some standard questions like kth largest number, and then kth smallest number, and then merge k sorted list. So these are all questions which we will solve using max heap, mean. Yeah, the property of max heap is we get the maximum element. We get the maximum element at the top. We get the maximum element at the top in the max heap. Okay, and we get the smallest element at the top in the mean heap. So these are the heaps. So arrays are very important, binary search are very important, heaps are very important. Then it goes for English. These are also very important. English is a very important problems are finding cycle, length of cycle, and then the starting point of cycle, merge case sorted list. These are very standard questions, like rotation of a linked list, removing duplicates from a linked list, finding palindrome of a linked list, adding addition of a number in a linked list. So these are very standard questions, and you should definitely do these questions. Then after that we have after linked list we have a very important topic of trees. Very important. This will teach you recursion very well. And in trees we have very important questions like diameter, and then maximum value number, then in order traversal, what is what is in-order traversal, what is post-order traversal, what is pre-order traversal, how we do in-order traversal using iteration. So in this, okay, then we go here pre-order traversal. In this we use stack. Then how we keep and how we do pre-order, in-order, post-order in a single iteration. So these are the questions which are very important questions. Okay, and the interviewer will definitely ask. Yeah, the interviewer will definitely ask this question. So be prepared. So be prepared with this all type of questions. Yeah. After that, after trees, uh, there comes tag and cues. Some very standard questions are also on this, like trap water, running water, like next greater element. Okay, so these are standard questions. Then we have graphs, we have DFS, we have BFS, we have topological sort. So these are very standard. These algorithms. These four to so these DFS BFS algorithms are very important for in graphs, in dynamic programming. We have various type of patterns, like the first one is 01 knapsack. So this is a pattern we interviewer generally ask. Then we have one type of pattern. What we got? Here we have Ruby arrays. Then we have then the robber. This robber one is also very important one. Yeah, robber, like there are multiple houses, but one robber. If the robber robbed this house, then he is not allowed to rob this house. So like robber can rob multiple alternative house, not the continuous houses. So this is one type of problem. Then 01 knapsack is a problem. So these are very standard problem, like staircase value problem. So yeah, this is a Fibonacci pattern. It follows f of n plus f of n minus 1. Now f of n minus 1, f of n minus 2. So this type of patterns with then we have greedy algorithms. So greedy algorithms are also very important, because these are the patterns we generally didn't see. Okay, so that's why interviewer ask. So in areas some important problems are like finding palindrome, longest palindromic sequence, subarrays, this type of question. Then in backtracking, these are also very important topics in backtracking, like how to find various patterns. Okay, so these are all for SDE interviews. So must, without it we are not going to pass any. SQL basics are also very important for data science roles. And then Python. These three are must with DSA, SQL and Python. These are must for data science roles, for data analyst roles, for business analyst roles, and for software development roles. So these are Python, SQL, DSA, Python, SQL. So these are the important ones. So what we could do to improve? Do you know what we could do to improve our? These are the topics. Do you know something that you have in your mind, and I will implement that in preparing the interviews. Let's say a link list. Okay. Find the intersection point of all English. Okay. So one type of problem is how to find the middle. How to find middle of all English. So in this case also we can use slow fast method. Okay. Then for detecting a loop in slow fast, for middle we can use, for cycle we can use, for the length of the cycle we can use, for deleting a middle node, for this also we can use. Okay, so then starting point for, so these are 5 to 6 questions we can we will use fast and slow method. And then after delete all occurrences, let's say here we have 6, so we want to delete 6 from all the occurrences, so we can use then find all pairs, the sum. Let's say we have a sum of 6 and we want to find the pairs in the list which can sum to 6. Then after remove duplicates. If the link list has duplicate, then remove that. How we can do that? So these are all the problems which are very commonly asked in the questions. Like if you have a link list and then you want to use the in K groups. So this is also a very important problem. Then you then rotate a link list. We have a link list. Then you want to rotate the link list like 1, 2, 3, and then after rotating this will become 3, 2, 1. So how we use that? How we rotate a link list and merge two sorted lists? How we can merge the two sorted lists? So in this we can use, this is a link list and this is a link list 2, 4, 6. So we can use T1, T2 pointers and then compare both of these, and after that like T1, if T1 is less than T2, then make a dummy node -1 and point it towards 1, and then increase this T1 to the next 2, and then compare it. If both are equal, then then do that and increase anyone, then it is compare this, then add, then compare, then move next, and by this method we can use merge. Then after we have flattening, and then after that merge case sorted list. Then we have sorted list. We have linked list, and how we will sort the question. Okay, in clone and link list. So in merge case sorted list, so we have case sorted list, and how we can merge this question. So push all the heads inside a mean heap, and then take the top and create a link list. So this is the method in the merge case sorted list. In flattening, what we are doing? So in flattening, what we generally doing is merging two sorted lists, merge these two, then these two, then these two, and this will become a single list. So merge two sorted lists is using is used a lot in these problems. So yes, these are very important. Then in arrays we have very important question. We have some very important questions. Yeah, obviously. And after that, what we will is इसके अलावा कुछ है क्या मेरे पास, मतलब डी से करने के अलावा मेरे पास कुछ है क्या, कुछ कर सकते हैं क्या? सो गाइस